So we have a text file here, which is nothing but a license document. And I am trying to do a word count or word frequency count on this license document. So the first thing which we need to do is copy this file into HDFS. Before that, let me make a folder in HDFS. So root, user root. I'm just trying to make a folder in HDFS. You can make it at your user level, and what I'm going to do is, let's say MapReduce example 1. Okay, so this is the folder I'm creating. Okay. I think I already had one other folder. Okay, so it should go. Now it's in this folder, and I will put the license file into that folder. Put this license file into this folder. Okay, so my input is now ready. That clear? So my input is in this folder. So I have a text file which I have put into this folder. So now I want to run a word count, a MapReduce program. So what I will do is Hadoop jar. FS was for file system. Jar is for executing a MapReduce. So I say Hadoop jar, then give the jar name. Okay. Then give the input path. So input path only folder has to be given, not the file. So give the folder, and then you give another folder where the output has to be created. And this folder should not exist. This it will create by itself. So MapReduce output 1. Okay. So the moment you start this, the map job will start executing.
I think you created this jar at project level, or is it a package level?
No, this is this project only. I created the jar at the whole project.
Oh, okay. Because the project has only one program right now. Is it correct?
Yeah, correct. So that's the reason I created like that. So usually what we do is, even if it has multiple program, yeah, so we create the whole thing, but don't have so many main class. You only have one main class. And from there you just call which MapReduce you want to do based on the parameter.
Okay.
Okay. Yeah, so let me explain it one more time what I did, and let's see the output after that. Okay. So what I did is, last time we had created this program, the MapReduce program, and I had compiled it and shipped it into this location. Okay. So this program is here. This is the word count jar. That day, August 30th, which we have shipped, that jar was here. Okay. So what I did is, I created one more file called license, which is a text file, pure text file. And I'm looking at this as my input file on which the word count is going to execute. So the first step is to move this file to HDFS. So I created a folder in HDFS. So I'll show you. This is the folder I created in HDFS. Then I put that file into HDFS. Okay. After I put the file, I have run the job. So I say Hadoop jar. This is the word count.jar, and the jar needs two parameters, correct? As per our new driver program. So it needs arg of 0 and arg of 1. So I gave two parameters, input folder and output directory. So Hadoop jar word count, input folder, output folder. So when I run this, the output is created in this folder. So now we can go to that folder and see what is the output. So you see that there are three files which exist in there, two files and one directory. Actual output is this, the part 001, because there is one mapper which has run, hence only one part has been created. Now why one mapper has run? Because the file was only small and it only created one split. So if you see, this file is only 32 KB. So if the file is only 32 KB, it will reside in one block and hence only one mapper runs. So if you increase this size, let's say more than 64 MB, you will see more outputs files getting created. So every mapper will create one output file. Okay, every reducer will create an output file. So in this case, there is a single reducer, so it gives a single output file. So now what I am going to do is, I am going to see what is the content of the file. So I put this and okay. So if you see the content of the file, you will see the word count. So word and the frequency. Word and the frequency. So this is what you could see. Now you could actually see that there is like lot of variations on this. So this is all because we didn't do any cleansing. So ideally we should do all the cleansing. So these all should have got merged together. The use all will get merged together and so on. But since we don't do any cleansing, we have got this output. Any questions on the word count example? So we created the program, we shipped into the cluster, we gave the input file, we created the output folder, we okay. So this is the code you write. This code you write for because you want to write a MapReduce. Okay. If you don't like MapReduce, yeah, there are other options. But if you like MapReduce, this is the option. You write the program like this, compile it, create it, put it on the cluster. So what essentially happened? So let me just show you what really happened there. And we should look at inside MapReduce execution. I hope you guys are downloading the jars and all.
Yeah.
So I'm just going to, I'll show you what really happened behind the scene now. So this was my machine. This is my client. I'm on my laptop. Okay. I created a jar. This is my word count.jar, which has three parts to it, which has inbuilt Hadoop client into it. Correct? Hadoop client and the map and reduce program. I shipped it to the cluster, which essentially means, let's assume this is on my Unix machine now, and I from this particular command line, okay, this particular Hadoop command line, called the job tracker. So I actually invoked the call to the job tracker and told him that this is the program, this is the input directory, this is the output directory, execute my word count program. That's what I told him. So what job tracker did is, it contacted the name node, to figure out where these blocks are there for the input directory. So it contacted the name node. After it has found it, it knew that yeah, it is in a few task trackers which exist. So these are the data nodes where the file is existing. So then it decided, okay, and the slots were also available in these machines. So the job tracker decided that we will execute the job here and here based on the availability. Okay. It also decided that maybe I will run the reducer on this machine. So first it decided where the mapper will run. Then it decided, so let's call this as map 1. Then we'll decide as map 2. So two mappers it decided to run. Let's assume the input was in 2 blocks. So one map here on this machine and one map on this machine. It also decided to run some reduce. Let's say for run reduce only on one reducer. Okay. So it will maybe decide let runs reducer. So this is what it has decided. Now it has delegated to the task tracker. The task tracker spun out the map one task, read the one box and executed that and created some output. It is my intermediate output. Let's say I call this as my intermediate output, which is on the local disk of that particular node. On this node it is there. Okay. On this load the output is created and kept. Similarly, this guy had created output and kept. Now it has decided to run single reducer, so only single output will be created. Now when the reducer starts off, it goes and pulls the file. So it pulls from here and it pulls from here and ran the reducers. Once the output was created, let's call this as the output of reducer. Okay. Now the reducer output is created here. Then this program actually contacted the name node and puts this file into HDFS. Okay. So now since this file is in HDFS, this got splitted into let's assume this file is also big. Okay. Then this would have got chunked into blocks and shipped onto the cluster. So this is chunked into blocks, small blocks, and one block might be residing here and maybe the other block also residing here. Okay, so this is how the final output will be there, and this file is now in HDFS, which is in the output directory. So when I go to that directory and I say browse, I get this particular file. Any questions? So this is what happened right now. Any questions? So now,
so if there are two reducers, for example, if you go back to your diagram, the two reducers will be, each one will be on each
yeah, if it was 2, it would have run it like
each node.
Yeah.
Right.
And here there will be 2 files now, because after the hashing, partitioning, there would have created 2 files.
Right.
Okay. So, and this would have been 2 files. And hence, this reducer also, let's say this is reducer 2, would have picked up its file from the other 2 places. Okay. So it would have picked up like this, created files here, which would have gone to name node and sent it back to the same node. So this would have been how the output would have looked like.
So they will be 2 separate files in the, like output. You were saying.
Yeah, it will be 2 separate.
2 output files.
Correct, 2 output files in this folder. If you go to this folder, output folder, you would see part 001 and 001. So every reducer will create one file.
Okay.
So if there are 10 reducers, it will create 10 files.